This one is second question from atomic physics. There are three naturally occurring isotopes of a hydrogen, which is 1, hydrogen 2, and hydrogen 3. The nuclide notation for hydrogen 1 is 1, 1. Write down the nuclide notation for hydrogen 2 and hydrogen 3. You can use a screen annotation to complete this, like how we represent hydrogen 2 and how we represent hydrogen 3. That's the question. If hydrogen 1 is represented by 1, 1. Uh, this won't be correct. Why it won't be correct? Because you're changing the proton number. Like if you change the proton number, the element will change. The proton number should be same for both of them. Like even hydrogen 1, hydrogen 2, or hydrogen 3, they all should have a same proton. But they should have a different number of the neutrons. That's the difference between isotope. So if you write hydrogen as 2, like you write 2 and 3, that is wrong. Why it is wrong? Because this won't be hydrogen, this will turn into helium. So hydrogen 2, 1 and hydrogen 3, 1. All should be, because they are isotopes, they should have the same number of proton, but different number of neutrons. The next one, in fusion reactor, a nucleus of a hydrogen 2 and a nucleus of a hydrogen 3 undergo a fusion. State what is meant by a nuclear fusion. So the mark distribution, yes, you can use a screen annotation, that's good. You can use screen annotation or a chat to state the answer. So one mark is for when you mention a lighter nuclei, and one mark is for mentioning form a heavy nuclei or a nucleus, because lighter nuclei is a plural and a nucleus one. Sorry. So lighter joined to form a heavy. Lighter nuclei, it's a plural here, joined together to form a heavy nucleus because it produced one. That's why we say nucleus. And by releasing energy, you can also add. The fusion reaction produce a free neutron and other particle. Write down a nuclide notation. That equation represent this. So first we have hydrogen 2, 1 combined with hydrogen 3, 1. When they combine, what they form? They form a heavy nucleus, which is helium here, plus a neutron. So that will be 1 and 0. As I mentioned here, in a fusion reactor, the hydrogen 2, a new isotope of a hydrogen which is having a nucleon number 2, combined with the isotope of a hydrogen with a nucleon number 3. So when they combine with each other and they mention, it is giving a free neutron and another particle. So there's a neutron is 1 and 0. How we identify the other particle? So because the total nucleon number should be same and the proton, so 2 plus 3, that is 5. So here we have 1, so there should be 4. 1 plus 1, that is 2. Here we have 0, so this should be 2. And element which is, how we know it is a helium? Because the proton number 2 is helium. Hydrogen is proton number 1, helium is proton number 2. And how we identify it should be 4, because the nucleon number at the top, this is 2 and this one is 3. 2 plus 3, 5. So as a neutron, dimension of free neutron is there. So if the neutron is symbol 1 and 0, so if 1 is here at the top, so how much we are, like how many particles we are left? 4. And at the bottom, proton number is 0 here. So how many, because total on the left hand side 2, so total on the right hand side should also be 2. That's a nuclear fusion equation. Better learn this. The nuclear fusion in the sun is a source of most, but not all of the resources that are used to generate electrical energy on Earth. Like we use solar energy, mostly it is used, like solar energy causing the water cycle or a movement of the air current, we can use state two sources from which a nuclear fusion in the sun is not the source. Like sun is not the source of that energy. It's related to the work energy and power topic, this part specifically. So core of the earth, so you can say that as a geothermal is one of them. What else? Other than geothermal, tidal, good. So tidal energy is the second one. Tidal energy is due to the gravitational pull of the moon. Even you can mention nuclear fission reaction on Earth. Nuclear fission reaction on Earth, so sun is not the source of it. Yeah, nuclear energy which we use on Earth, the sun is not the source of that.